Okay, so we've talked about concentrations, and we've talked about how to calculate concentrations, what they mean. Now we're going to do something to sort of a natural jumping off point from that, and that is we're going to talk about dilutions. Okay, dilutions of solutions. So in a dilution, a solvent, usually water, is added to the solution, which increases its volume and decreases the concentration of the solution. Making orange juice from a concentrate, for example, is shown below, right? So you can take this sugar, water, orange juice concentrate, which is basically like, oh, I don't know, almost a sorbet, right? It's very, very thick orange juice, right? And if you add 3 cups of water, 1, 2, 3, then you get what is supposedly like a normal pitcher of orange juice, right? So what happens? What happens to the orange? How many oranges did I have here? Or I should say maybe, how many cans of orange juice did I have here? How many cans of orange juice did I have here? I had 1 can in both cases, right? 1 can here, and 1 can of orange juice here, right? Of the orange pulp, 1 can. But I had a more overall volume, and that is my volume here was increased, and so my concentration was decreased, my concentration of the orange pulp, right? All right, so our learning goal for this section is to describe the dilution of a solution, which we've sort of just done. We're going to do it again. And we're going to calculate the unknown concentration or volume when a solution is diluted. All right, so let's go again to what we mean by a solution. In a solution, you've got 2 components, right? You've got the solvent and the solute, right? If you add more solvent, the amount of solute does not change. Right? In a dilution, solvent is added. And so the volume of the overall solution increases, but the concentration decreases, right? Because the mass of the solute does not change, right? So it just gets more dilute. You've seen things like this before in just regular old life, right? So let's talk about concentrations now. In the initial and diluted solutions, the moles of the solute, or the actual count of the solute, are the same. The concentrations and the volumes are related by the following equation. C1V1 is equal to C2V2. That is the initial concentration times the initial volume is equal to the final volume, or rather the final concentration times the final volume. This equality is written in terms of the concentration C and V. And the concentration could be percent or it could be molarity. It doesn't matter. All right, so again, just another picture of this, and then we'll do some examples. So suppose you've got some red Kool-Aid here, right? And if you take your red Kool-Aid and you add water to it, the volume goes up, but the amount of Kool-Aid particles does not change, right? So the concentration goes up, the volume goes up, and the concentration goes down, right? C1V1 is equal to C2V2. Let's do an example now. All right, so what is the final concentration? All right, so what I'm asked here is, what is the final concentration? C1V1, C2V2. This is what I'm being asked here. What's the final concentration when 0.5 liters, looks like that's the initial volume, 0.5 liters of 6.0 molar HCl is diluted to a final volume of 1 liter. C1V1 is equal to C2V2. So C2, right, I divide both sides by V1, is C1V1 over V2. And I'm going to argue this is relatively straightforward. Okay? So it looks like it's going to be, and let's put the units in here. This was molar. This was liters, and that was liters. Liters cross off, so it's going to be molar. Looks like it's going to be 6 times 0.5 is 3, right? And there's our answer. It's going to be 3 molar. All right, so what I did was I said, the hard part, I think, is interpreting everything correctly. And then, of course, knowing that C1V1 is equal to C2V2. All right, so pause the video and do this problem, and then come back and check your work against mine. We're gonna finish this video out by several examples. Okay, so I'm going to suppose you paused it. What volume? So it looks like C1 V1 is equal to C2. How do you spell V? Like that, I think. C1V1 is equal to C2V2. C1V1 is equal to C2V2, right? What volume of a 2% HCl solution can be prepared? And so that is what I'm being asked right here, right? If that's what I'm being asked, then C1V1 is equal to C2V2. V2 is equal to C1V1 over C2, right? So what volume of a 2% solution, so it looks like I'm trying to make a 2% solution, I'll just leave it in percents, can be prepared by diluting. Initial volume is 25 mils of a 14% solution. 14%, right? And this is in mils. So this is also going to be in mils. Okay, so C1 is 14. V1 is 25. And C2 is 2. 14 divided by 2 is 7. 7 times 25 is 175. 175 mils, and there is my answer. Okay, please pause. Let's do another one. We're going to do 2 more. Pause the video and do your own work, and then come back and compare your work against mine. Okay, I'm going to suppose you paused it. Remember, C1V1 is equal to C2V2, right? What is the percent of a solution prepared by blank? All right, C1 is equal to V1 is equal to C2 is equal to V2 is equal to, right? What is the percent of a solution? So it looks like this is what I'm being asked. Is prepared by diluting 10 mils. All right, so it looks like that's 10 mils, and it's initially 9%. And I'm going to 60 mils, okay? So mils and mils are going to cross off, and 9 is a percent, so it looks like this is going to be in a percent, okay? So C1V1 is equal to C2V2. Looking for C2, so I'm going to say C1V1 over V2. C1 is 9. V2, no, V1, sorry, is 10. And V2 is 60. Okay, 9 times 10 is 90. Over 60 is 1.5, right? 90 over 60 is 1.5. 1.5%. By the way, does that make sense? Going from 9% to 1.5% in a dilution? Yes, it absolutely does. Okay, let's do one more example. Pause the video and come back and check your work against mine. Okay, let me suppose you paused it. C1V1 is equal to C2V2. What is the molarity? C1 is equal to this, V1 is equal to that, C2 is equal to this, V2 is equal to that. What is the molarity of a solution prepared by? So I'm asking for a concentration prepared by C1V1 is equal to C2V2. C2, which is what I'm being asked for, C1V1 over V2. Let's put these numbers in here now. C1, prepared by diluting this much, that's my V1, 180 liters of a 6 molar, or 0.6 molar, okay, 0.6 molar. And I'm going to 0.54 liters, 0.54, and I have a feeling those are even multiples, okay? C1 is 0.6. C2, or rather V1 is what I'm looking for next, is 0.18, right? And 0.54 is V2. 18 goes into 54 3 times, so I'm going to say that's 1 over 3, and 6. It looks like it's going to be 0.2, 0.2, and the concentrations were molar, liters, and liters. So liters will cross off, and I'm left with 0.2 molar, right? 0.6 over 3 is 0.2, and there is my answer. All right, hope that's helpful. Go do some more practice. Good luck.